So hey everyone, today we are going to solve one question of graph. That is, we want to simply, if we want to, uh, let's say, if we have given a graph and we want to identify that if this graph is bipartite or not. So simply, today we are going to discuss the topic bipartite graph. So so simply first we will see what is the term bipartite graph. So let let me explain. So bipartite means if we have given a graph and if we are able to color a graph with the, we can say, two different color and no adjacent node have the same color. So let me explain with this term. So let's say this is our graph. So let's say this is 0, this is node 0, this is node 0, and this is node 1, and this is node 2. So there are these are the edges between them. Okay, so these are the edges between them. So this is node 0, this is node 1, this is sorry, node 2, and this is node 3, and this is node 1. So bipartite graph means if we have given a graph and we are able to color a graph and such that we are able to color a graph of nodes such that no adjacent nodes have same color. So let's say if I color this node 0 with color red, and let and we have to do the colors, two different colors. So let me do the color of this node 2 will be, that is yellow. Let's say I am doing yellow color in that node, and let's say this is also. So we have limited two colors, so we have to we have only two choices. So if we can do we can do red or yellow. So if I choose red, then also this graph is not bipartite, because this adjacent node, that is node 0 and 3, have same color, that is red and red. If I put yellow color in this node, then also this node, adjacent node, that is 2 and 3, will have same color. So this graph, we can say this is a not non bipartite graphs. Okay, so let me give another example. Take on another example. uh, let's say this is node 0, this is node 1, this is node 2, this is node 3. Okay, and this is node 4. So let's say if I am coloring this node, that is node 0, with color red, and this node with yellow, this with red, and this will yellow, and this is red. So this is the example of bipartite graph. So you have seen in this in this example that we are able to color all the nodes with the different colors. Okay, and no two adjacent nodes have the same color. So this is the property of bipartite graph. So so one thing you have noticed there is, if we have an odd cycle, that is odd number of nodes, and if we have cycle with odd number of nodes, so this then we can conclude that this conclude that this graph is non bipartite. And if we have cycle with even nodes, if we have even nodes, we can say cycle with even nodes, then we can say it is bipartite graph. And and any linear graph that has no cycle is always a bipartite graph. So let's say I am taking this example of linear graph, that is, let's say this is linear graph. So it is always bipartite. and it does not contain any cycle. So let's say this is node 1, this node 2, and this is node 3. So if I put yellow color in this node, so adjacent will be red and this will be yellow. So this is bipartite graph, because we are able to color these adjacent node with different colors. Okay, so this is the term bipartite graph. So how can we done this, we can say this concept of bipartite graph? So we can done with the help of the that is DFS traversal. So we will what we will do, we will simply take the graph and we will try to put the different colors to the adjacent nodes of the graph. So what we will do, we will take the help of the DFS algorithm. So as you all know that what is DSF algorithm. So DSF algorithm, we can say DSF is a technique which uses the idea of regression and backtracking, in which what we will do in DFS, we go depth wise until uh, until there is no further nodes, and when the node all the nodes are covered, we can say, or we are reached to the end. So we traverse back, so we simply traverse back. Okay, so this is the DFS algorithm, and we traverse back, and we cover another unvisited node. So this is the BSF algorithm. So let me explain how can we use this DSF algorithm in this to identify the graph whether it is bipartite or not. So let me take one example, that is this is the example of the graph. So let's say this is node 1 and this is node 2, this is node 3. Okay, this is node 6, this is node 4, this is node 5, node 7, and node 8. So if I call DFS from let's say this first node, then what we will do, and we are representing the colors with the that is integer number, that is 1 is denoting the red color and 0 is denoting the yellow color. Okay, this is a red color and this is yellow color. So in this case, in this we can say bipartite graph, what we will do, we will take a color array that will be first initialized with the -1. Okay, -1 indicates that there is no color in the graph, or we can say that that node is unvisited, or we can say we we haven't put any color in that node. Okay, so let's say if I start the DFS from the node first, that is node 1, and I am taking the color 0. Okay, then from node 1 I can go to node 2. So DFS of 2 will be called. Okay, DFS of 2, that is color will be changed, that is 1. So from 2 I can go to node 3. Node 3 comma 0. Okay, from node 3 I can go to node 4. That will be 4 comma 1. And from node 4 there are two paths available. The first path will be that is DFS of 7, 7 comma 0, and DFS of 5 comma 0. And after that DFS of 1 will be called, sorry, DFS of 6 will be called. There is DFS of 8, color will be 1. So what we are doing here is we are starting the DFS from node 1, and let's say we have painted this node with color yellow, and then we will move to the next node, that is node 2, and we will put the color that is red. And from node 2 we can go to two paths. That there are two paths available. The first part will be node 3 and the second will be node 6. So there will be node 6 also, node 6 comma 0, that will be because it is already, we can say, visited, so we will not explore this path. So first of all this left will be resolved, then we will go to node 4, then we will go to node 7 and node 8, then and so on. So here one thing you have noticed, that we have an cyclic graph with an odd number of nodes. So let's say this is 1 2 3 4 5 and 5 number of nodes there is. So this is definitely a bipartite graph. So let's say if I have painted this node with red, then I have painted this with yellow, then with red, okay, then with yellow, then with red. So here you have seen that this these two adjacent node have same color, that is red red, okay, red red. So this is the example of non bipartite graph. So we will simply return the 0, simply we will return 0. So let's say we will take another example. So let's say I am taking another example. Let's say this is node 1, this is node 2, node 3, node 4 and node 5, okay. So if I color this first node with color, let's say with yellow color, so the adjacent will be a different color, that is red, that is yellow, and that is red, and this is yellow. So here all are that you have noticed that we are able to color all the nodes with different colors, or we can say we are able to color adjacent nodes with the different colors. So this is the bipartite graph. So what we will do, we will simply make the DFS call from node 1, okay. We will simply make DFS call from node 1, and node 1 has two paths, that is 2 and that is 4. So node 1 go with the 2, and it will change the color to red, and then it will go to yellow, and it will change to red, and then 4 it will change to red. So this is the example of bipartite graph. So simply let me explain with the help of the code. So let's directly jump into the code, and we will simply what I can say, simply I will explain the code with the help of the examples. So here is the code. So what we are doing here is, so first of all we are initializing the color vector, which will be storing our color of that particular node, and then what we are doing, initializing that particular color vector with the -1 indicating that there no color is present in that particular node, okay. Then what we will do, we will try to iterate over the all the nodes, okay. Then if we are we haven't visit that particular node, or we can say we haven't color that node, so we will direct simply make the DFS calls, and if our from the DFS call is if our answer is coming false, so then we have to return the false, else we have to return true. So what we are doing here is we are simply we are making the starting node with the color that is with the color 0, Okay, we are first of all we are current color with are passing with the 0, that is 0 is indicating the yellow color. Okay, then we are moving, what we are doing, we are exploring the neighbors of that particular node, and simply we are changing the colors of that particular node. If it is coming the false, then we have to return false, else we have to what we can say, if our previous color is coming to the current color and previous color, that is means adjacent nodes have the same color, then we have to return false, else we have to return the true. So this is the simple code for this, we can say, bipartite graph. So you can see this. So that's all for this question, for let so let's meet in the next video. So till then, bye bye, take care.